Very early computers could only run one instruction at a time, and so they couldn't run efficiently without human intervention. However, in the modern day, computers run on what is known as the volume and architecture concept. It is a process of fetching, decoding, and executing instructions that are stored in computer memory, and it allows computers to run in a much more user-friendly and efficient way than they did before.
One action. We don't really need sound here. I want to speed this up when we're
Okay.
all right. Here for you to yeah, okay, 3, 2, 1, go. Alright, so as you can see over here, we have the address bus, the control bus, and the data bus. What the address bus does, it carries signals relating to the memory and the processor. So it carries signals to the memory unit in order to fetch the data that has been saved within the memory unit. Also, you have the control bus. The control bus sends data between the processor and the memory unit and input and output devices, so it controls the flow of inputs and outputs within the CPU, and also manages hardware and makes sure everything is ready when the computer starts up. And now we have the data bus. What the data bus does is it carries the data between the memories. So what the data bus does, it also focuses on a lot to do with the memory unit, and it also focuses on collecting the data and coordinating the data sent between the processor and the memory unit, which will then which will decode and then execute the actual data itself. Yeah.
An important factor of the volume and architecture is the concept of registers. Registers are simply a high-speed storage location in computer memory where data must be represented or stored before it can be processed. Now, there are a number of registers, and they are found in the various components of the aforementioned diagram. So, in the control unit, you have two types of register. There is the program counter, which stores the address of the next instruction to be fetched, and then there is the current instruction register, which actually holds that instruction. We will go to addresses in a moment. Then there is the processor. And while this isn't actually a register, it is highly involved in the fetch-execute cycle, and so must be mentioned. The ALU, the arithmetic and logic unit, which can carry out arithmetic operations as well as logical operations. Arithmetic operations are things like addition, subtraction, multiplications, and logical operations are things like and, or, and not. Finally, we have the memory unit, and the memory unit contains two registers, and these mostly are interacting with the control unit. So the two registers are the memory address register and the memory data register. Okay.
One action.
The memory unit consists of partitions. Partitions are made up of two components. the address, and the contents. Now the address is simply a unique number that identifies the location of the content in which the actual bytes of data are stored. And that's all there is to registers and in the memory unit. Okay, we're gonna cut that one out. It's bad. At the end, like.
On an action.
Finally, we must understand how all of these concepts mesh together in the volume architecture. The first step in the fetch, decode, execute cycle would be that the address of the instruction to be fetched will be stored in the program counter. This address will then be copied using an address bus to the memory address register in the memory unit, all the way from the control unit. The memory unit will then get the instruction from the memory unit itself, stored in that address. So the address will point to a certain partition, and then the contents of that partition will be copied to the memory data register. So now we have the instructions stored in the memory data register. What will then happen is that the contents of this memory data register, i.e. the instruction, will be copied to the current instruction register by means of a data bus. So this here is an address bus, and that there is a data bus. Finally, the program counter is incremented by 1, so that it now points to the address of the next instruction to be fetched. And since the current instruction register currently contains the instruction that needs to be executed, it will first decode the instruction and then execute it by sending out various control signals using the control bus to different components such as the input and output devices in the computer in order to run the process in a logical sequence.
As you have seen and heard, Omar and I have clearly described how a fetch, decode, execute cycle will work and how it would how it would affect the hardware, such as the input and output devices, as well as how everything would work and be coordinated within the CPU. So thank you for listening, and we hope that you learned a lot. So yeah.